Alrighty, this video here is on combining like terms, also using the distributive property to do so. So we've got some vocab first. So a term is just a number of the product of a number in variables. Sorry, that should be or. So not a number of, that should be or the product of a number in variables. So 10, 7x. So those are terms. Okay. A constant is just a term that has no variables. So negative 12, 7, 3, 5. Those are all constants. Now, like terms, this is the important part. They have identical variables. Okay. Now, identical variables means not only are the variables the same, but they have the same exponent. So 3z and 16z are like terms. 5x squared and 2x squared are like terms. But 3x and 4x squared are not like terms. Okay, this is x to the first, this is x squared. They're not like terms because they're not identical. Okay, one's x to the first, the other's x squared. They have to be completely identical. Coefficient can be different, but the variable has to be the same. Okay, and lastly, a coefficient. That's the number we multiply by the variable. Okay, so in this case, 14. So 14y, the 14 is the coefficient. Now, most of these should be familiar to you. If not, you still need to, then this is something that you're going to want to memorize because these are words you're going to hear all year long. Now, in order to combine like terms, in order to simplify, we follow the 3 little steps. Okay, we clear the parentheses if there are any by using the distributive property or order of operations. Then we combine like terms. Now step 3 says combine constants, but that's pretty similar to combining like terms because constants are terms. Now, these shapes over here are just one way that you can do this, and they're not something you have to do. That's just something that some people sorry, let me try this again. It's something that some people find helpful. Okay? It is not required by any stretch of the imagination, but some people find it easier to identify the like terms. So, for example, they would take a circle and say, well, that's a B, and you're supposed to come with me, and that's a B. So there's my like terms. So we have a constant, nothing else. We have a y, nothing else. So those are unlike anything else. So we do negative 13 plus 2. That's negative 11. B. Okay, the variable doesn't change, it doesn't go away. Now, there was nothing to combine the 5 with, so plus 5. Nothing to combine the 3y with, so plus 3y. Now, 8a plus 5a. Again, we can do this. We don't have to. But we identify which ones are that. In this case, 8a plus 5a. Well, that's 13a. Now, if you wanted to use a triangle instead of the circle, that's fine. Rectangle, fine. I don't care if you draw trapezoids, as long as you're identifying which ones are the same. Okay, we have a negative 4m and a minus 9m. So negative 4 minus 9, remember your integer rules. So negative 4 minus 9 is negative 13m. Now this is one where we have to use the order of operations first. We have like terms here and here, but we need to get rid of these parentheses. So 2 times 3. So we've got 2x plus 4 plus 6x. Now I've got 2x plus 6x. That's 8x. And then I've got this little 4 that's hanging around with nowhere to go. So plus 4. And I'm done. Now this one, I've got two sets. I've got 8a plus 5a, and I have negative 1 minus 9. Okay, you have to get used to that this minus sign is a subtraction and a negative. Okay, you got to realize it's both at the same time. So to take care of this, I've got 8a plus 5a, so that's 13a. You can probably hear Miss August's room in the background. I have no idea what she's playing. Oh, no square, that's bad, that's awful. Bad evil. Now we have negative 1 minus 9. So, negative 1 minus 9 is negative 10. Done. Now it doesn't necessarily have to be already with our like terms in order. Alright, I'm going to take a look at a couple more real quick. Okay, I'm going to skip down to this one, the 6y. Now, by all means, go ahead and try this. I'm not going to explain it in great detail or anything. I'm just going to show you the answer real quick, so if you want to try it. So if you want to pause and see if you get the same answer. Okay, what you should have ended up with was 6 plus 8g. If you have 8g plus 6, it's the same thing. Okay, this one you should have ended up with negative 2x plus, that's it, 17. If you've got 17 minus 2x, you're okay. It's the same thing. Okay, now this one, I wanted to talk about it because everything's not in order. Okay, so we've got 6y and a negative 7y. We've got a positive 4m and a positive 1m. So 6y minus 7y is negative 1y. Okay, or just negative y. Now, positive 4 plus 1 is positive 5m. So this would be the answer. If you have 5m minus 1y or 5m minus y, again, same thing. Okay, a couple of last ones. Okay, now, if you want to pause it and practice, see if you get the same answer, by all means do so. So we got 4x plus 3x. Well, that's 7x. We've got 2y plus 7y. So that's 9y. Then we have positive 5 minus 1. So that's plus 4.
I was writing.
She's doing good.
Good, good.
Sorry for that interruption. I paused so you didn't have to hear the conversation, and so I wouldn't make the video excessively long. Okay. Now, again, we look for the like terms. Well, we've got 2x squared plus 1x squared. So that's 3x squared. Then we've got 5x plus 6x. Well, 5 plus 6 is 11, so plus 11x. And then we've got positive 2 plus 4. So that's plus 6. Okay. Now, this one gets tricky. We have a y squared. There are no other y squareds. So we've got nothing to combine it with. We have a y to the first power. There's nothing else that is only y to the first power. So nothing to combine it with. We have a 3xy and an xy. So we can put those together. Now, I'm sorry, I went and finished the whole video and then didn't realize that it was still paused. So if I repeat, I'm sorry. So we've got 3xy minus 1xy, so that's 2xy. We bring down whatever we didn't use, so plus 5x squared. We bring down the 7y squared. We bring down the minus 2y. Now, since this was a positive 2xy, we put the plus sign. Now, I'm not going to move to reveal because I realized when in the part you didn't see that that was a wrong answer. There's a typo there. Okay, now I'm going to skip this one. I'm going to pause for a moment and put up a different one because there's something specific I want to show, and that'll be the last example. Alright, sorry, I was wrong. There are 2 more examples I want to do. Okay, so we've got 3a plus 1a. So 3 plus 1 is 4a. Oh, that's actually a word. And we've got negative 6 plus 4. So negative 6 plus 4 would be negative 2. Remember, just because it's subtraction, we look at the term individually. That's negative 6. And so that's our answer. Okay, the last actual example. We have to distribute. There's a negative in front of the parentheses. We don't see a number. So we assume there's a 1 there. And so we distribute the negative 1. So we get 10x minus 2 minus 9x. And then we combine all the terms. So 10x minus 9x is 1x, or x, either way. Bring down the minus 2. And those are all the examples. Now I am going to go back to here really quick, actually this one, and I'm going to say, just really quick, our terms for this example are 15, negative 2x, negative 8, and 10. Okay, where we separate it after the term and before the addition subtraction sign. And so those are the individual terms. Okay, that's why if we look at this alone, it's a negative 8. If we look at it all together, it's a minus 8. Like I said, that's something you have to get used to.